Hey, welcome back. Today we will talk about sex-linked genes. Let's go. Okay, cool. Let's do this. Now, gene disorder disease. Of course, first of all, you must have your basic on how to draw the schematic diagram. I assume that you already can. So here we are using schematic diagram also to combine sex-linked disease. So mainly in your syllabus, there's two types of sex-linked disease that you have to remember, which is color blindness and hemophilia. So color blindness, I'm pretty sure you understand means cannot see color 啦，色盲。可以是全部颜色看不到，可以是一种，可以是几种颜色。So the other one is called hemophilia. Hemophilia is where you lack of a certain protein in your body, in your blood, where you cannot clot your blood. 血不能凝固啊，就是受伤之后或者割刀还是什么，你的血不能自己凝固。Cannot clot your own blood. So you're supposed to clot, your blood are supposed to clot as you have wounds or you cut yourself or whatsoever. That's to stop you from bleeding. So that's the problem of hemophilia. Okay, so these two types. Why do we call it sex-linked genes? So let's take a look into this. So allows also carry diseases. Allow means all the chromosomes where you have genes. Genes comes in a pair. Remember dominant genes and recessive genes. So they come in a pair, hence we call them as allows. Okay, so allows also carry diseases trait that can be inherited in the family. However, genes that control traits are located in autosomes. So we have 44 autosomes. Usually diseases comes from there. But sometimes, however, there are also traits that located at sex chromosome. That means for the X and Y or X and X for male and female, usually they don't carry as much diseases, because most of them come from autosomes, which is the 44 of them. This is the last two already, okay, the 45 and 46, okay. Yes, this can carry certain diseases that pass on from parents to children, hence we call sex-linked genes, or we call sex-linked traits, diseases that will pass on, okay, that located at the sex chromosomes are called the sex-linked genes. Okay, so as I was saying, there's only two for you to remember. Number one, color blindness. Number two, hemophilia. Of course, we have more than this, but in your syllabus, your textbook only wants you to understand two of these, so let's not make you confused. So we have only two types as for now. Okay, so these are the possibility for male and female. Okay, for male, you can have two possibility. Number one, it's either normal or it's either having the hereditary diseases. Okay, so how do we represent? We use big H represents dominant, means okay. Small h represents recessive, means not okay, means having the disease. So writing the big capital H with the X means okay. Writing the small means not okay, means having the disease. Y will never carry diseases, only X, you have to remember that. So hence for male, 男生呢，你的几率只有50%, 50 only 50% So this is 50% tak kena, this is 50% kena. Okay, so male is very straightforward because it only the alphabet H only goes with X. It can be any alphabet, whichever. So hence, assuming H stands for hemophilia. So this is okay, no problem. This is with hemophilia. Okay. As for the female, there is three possibility. If it's okay, you write X big H, X big H. Remember, capital letter of H means no problem. But you have to show that it's no problem. So you write capital letter. Small h means no good. Kena. Big H, small h means carrier. So carrier basically is okay, but you will pass to the next generation. 你会遗传下去，你本身没有那个问题，可是你会遗传。So 女生们都有这个可能性，就是会 身为一个遗传者，就是你传下去下一代。Okay, must write capital H only small h. Yeah, it's always going to be like that. So hence, for females to kena hereditary disease by sex-linked genes, it's only 33.33333%. But male is okay, not okay. Female is okay, not okay. Meh, okay, but carry diseases. Okay, so this is how you write down the indicators. Okay, so let's say we have this as example. So a father with normal means no diseases, no hemophilia. Mother with carrier. Okay, so we do the same thing. We split it up through meiosis. So this is your answer already. Okay, then we combine as usual. 1, 3, 2, 4. 2, 3, 2, 4. It's like maths factorization. 1, 3, 1, 4, 2, 3, 2, 4. You have 4 columns below to fill up, so hence you need to fill up each. Settle number 1, ding. Go to number 2, ding. Number 3, ding. Number 4, ding. Fill up 4 of them. Okay, so this is the result that you get assuming you already know the schematic diagram. So XX, but 2 capital letter, 1 capital letter and 1 small letter. So for boys, for male, it's one, only stick with the X, right? So it's capital H and small h. Hence, here we have 25%, 25%, 25%, 25% equals to total 100%. So the chances of your children that is getting hemophilia is only 25%. Okay, out of 100%, 25%. Well, the son on the other side here will be normal because capital H. This is a carrier. This is a normal daughter. So that means if doctor tell you, okay, if you give birth to daughter, all your daughters will never get hemophilia because either they are normal or either they are carrier. No problem, no problem. But if you give birth to a son, the chances are 50%. Okay, if this is 100%, 50% okay, 50% not okay. So that's the result when a normal father marries a carrier mother with whatever diseases. This is the result that you will obtain. So it's about probability here. It's not like you will give birth to 4 children only. This is every birth in terms of probability. 就是算%率，不是说你只会有4个孩子OK 吗？是算%率来的。So the next one works the same way. This is a normal father marries a hemophilia mother. So as you can see, if mother hemophilia, the son confirm hemophilia already. If the mother has diseases, confirm will pass to the son. Confirm plus chop. Why? The theory is this. Because Y is that definitely from daddy sperm from daddy X is that definitely from mommy already. So if mommy gonna confirm, you will gonna as a son because your X comes from mommy. Y's come from daddy. So daddy, if Y no diseases, doesn't pass to you Okay, so mommy got diseases, son will inherit the disease. Okay, so for daughter will be carrier because half is from daddy. If daddy is okay, so this okay one must be from daddy This one not okay one must be from mommy Okay, so that's basically the probability. There's so many ways, so many probability you can draw, or you can answer in different types of probability, but I'm just showing you some of the examples. Okay, right, I think we shall try out some work, shall we? So please turn with me to question number 1 Okay, so you can download this material in the description box below, so help yourself. Okay, so I'll go straight into it. Question number 1, right? Diagram below shows schematic diagram. By the way, this is what we call the schematic diagram. Okay, so we have hemophilia diseases here. Okay, let's talk about hemophilia since we've been talking about hemophilia, right? So daddy lah, consider is colorblind. Why hemophilia and then colorblind one? I think there's a mistake here. Must be hemophilia. Okay. Female carrier colorblindness. Sorry, let's make some correction. This shouldn't be blind males, or this should be let's just cancel the whole thing. This should be hemophilia male. This should be female carrier hemophilia. Okay, so small alphabet represents got problem, recessive means got problem, got disease. Capital is to show that you're okay. So hence hemophilia male will be XBY. Okay, this one I know is at the bottom. It's okay if question we follow should be on the top then this is a carrier. Now you realize carrier, why like no lack of something one? So if it's carrier, you can also either write like this one, which is small b, or followed by what we have learned just now, which is a capital and a small letter. Okay, but it's up to what question wants, but usually you will have the capital letter with you. But since we don't have it here, let's leave it this way. Okay, all good. Right, so let's get into the question. You need to complete R. Okay, so try yourself. Most of the answer already given, so you just have to combine this and this. Okay, so that will be X small b y. So you see, once you have a small b, that represents that you kena already, especially for male. So this is daughter, carrier. This is daughter, hemophilia, kena. Okay, I should draw X actually, kena. Okay, and then XY, nothing we did, right? So we assume it's a capital letter if we have it here, but since question don't want, question only want to show small letter, okay, then we follow. So this one means okay, no problem. Okay, this one is a son, but this one not okay, kena. Okay, that means in this scenario, if you give birth to female, either 1 or 50% will be carrier, 50% will be healthy. But actually both no problem lah. Okay, if you give birth to son, it's 50-50%. 50% okay, 50% not okay. Okay, you get it? Right, so I think that's already number A1 lah. Okay, so we go to number A2. Now, based on diagram above, state the ratio of getting a normal, ratio of normal blood clotting offspring means okay one normal no problem one ratio right. So according to what we have not okay, this one consider okay, this one consider okay. Make sense? So if it's percentage, it will be 50-50 咯. But now question asks for ratio. 比分率就是要对比的ratio. So we have 2 versus 2 ratio. But let's simplify to 1 versus 1. So we always simplify that. Is that alright? There you go. That's how you write ratio. If it's 3 versus 1, then 3 dot 1. 3 colon 1. Okay. So predict the percentage of getting offspring with hemophilia if R percentage, if R cross with a female that has hemophilia. Okay, first of all, guys, R is X small b y from here. Okay, cross with a female that has hemophilia. If female that has hemophilia means X small b, X small b. Make sense? Yeah? Good. Okay. If you want to draw, go ahead and draw the sequence. But if you don't draw, jump in your head, which is the factorization. 1, 3, 1, 4, 2, 3. So I'm going to do it since we have no space for drawing that. Okay, so 1, 3. The first one will be X, B, X, B. Okay, next one, 1, 4. X, B, X, B. Okay, and then 2, 3. X first lah, huh? X small b, Y. And then 2, 4. Okay, oops. X small b, Y. Always X first, although you see like 2, 3, 2, 4, but we write X first, remember that? Wow, jialat. Okay, you see, if a father that is colorblind marries a mother which is also colorblind, confirm all colorblind. See that? Sure got B already ma. For female, two small letter confirm kena. In this case, a bit sad lah. That means 100% kena, percentage, not ratio. They will only either ask percentage or ratio. Okay, there you go. Next one. Men are prone to get hemophilia disease as compared to female. That means men usually get sex-linked disease like hemophilia, colorblindness, more chances than female. Justify. Okay, so remember we were saying that the percentage or the probability that we have just now, why male more chance? Because if you do the maths, it will be 50% for male, right? If you do percentage for female, it will be 100 divided by 3, so 33.33%. So isn't that more percentage? But of course, my point here is not to prove to you it's 50% or 33. My point here is to tell you why it's higher percentage for male. Okay, 几率男生一定会高一点啊，你自己看一下号码你就知道了。So the reason behind is because these diseases, especially sex-linked disease, only hang on to X. Y never one. So in this case, you can only no hang on or hang on, tak kena or kena. Make sense? Because there's only one alphabet here that will be hang on to the diseases ma. So if you see female has 2, it's either you kena both, tak kena both, one kena, one tak kena. Make sense? So we have to explain this because the disease only hang on to the X. So male has only one X literally, so hence the chances is always going to be higher. Okay, all cool, right? So how do we write that? So you can write that the gene of the male or of the hemophilia person, okay, is always on the X. Okay, so the gene for hemophilia, okay, is only carried on X chromosomes. Okay, so then the next thing is male has only one X chromosomes. So kena tak kena lah. That proves that 50% lah. For 2 marks, two sentences here that we have to explain. Okay, so gene for colorblindness or hemophilia 只会黏着 X 的罢了 ，Y 是不会黏的。这样男生只有一个 X， 就是黏或者不黏，得到或者不得到，这个很明显是50%的事情啊。Okay so hence male has a higher chances Okay. Yeah, so like last one, give one other disease which similar to hemophilia. Well, like I mentioned, you have only 2 in your topic right now that is sticking to the sex chromosome or sex link diseases or sex link genes, right? So the other one will be color blindness. Okay, color blindness. Is that alright? Okay. I have one more for you to try, question number 2. A bit challenging because you terbalik find out the parents. I give you a little bit of tips to help you. Remember, my tips here is Y is always from daddy. Okay, then you know X is from mommy 了啦. But anyway, the description is already here for you. 他已经讲了，他这个是什么，你应该懂得要怎么写出来了。它是 XCY 什么，这个看这一个你就知道。Look at this, already kind of hint you, but my more important hint here is from male. Y is from daddy. X must be from mommy. Mommy. Okay, I think you can do that. So help yourself with the rest of the question. Not super difficult. You can try on, and answers are in the material for you as well. Alright? Okay, I hope this video helped. If you like it, give me a thumbs up. Consider to subscribe and share it to your friends. I guess I will see you in the next one. Bye guys!